Hey guys, Miss Kennedy here. Let's take a look at graphing exponentials, and mostly we're looking at the transformations. So here's a graph of an exponential function. This is called the parent function, y equals 2 to the x power. This is just considered the most basic sort of exponential. And think about why it's called exponential. It's got an x in the exponent, right? And exponentials always have this shape. Some people call it the hockey stick shape. It kind of looks like a hockey stick. Okay, but it shows that the graph is growing very, very slowly at first, and then it just like takes off, right? And so that's exponential growth. It's going to grow really fast. And so this is the most basic one. And notice a couple of key points. There's a y-intercept here at 0, 1. There's something called an asymptote that is running really close. It's almost hitting the x-axis. And so we would say that the x-axis, or y equals 0, is our asymptote there. And so the graph is approaching that number. It's actually not ever going to hit it. It's not ever going to land on it. But forever and ever, it's just going to get closer and closer and closer for infinity, which is wild. Okay, let's keep going. So I want to show you a couple of transformations. Notice the difference in the graphs, and also notice the difference in the equations. So two things that I want you to pay attention to. Take a look at the equations here compared to the parent. Take a look at the graphs and some of those key points compared to the parent function. All right, so hopefully you noticed that the number at the end has changed, right? The number that's down in the regular function, it's not up in the exponent. And so that is a change. One has a +1, one has a -2. Notice where the y-intercept is here. It's up at 0, 2. The y-intercept here is down at -1. -1. Yep. Okay. So what does that have to do with this? Oh, and we also have a new horizontal asymptote where this is approaching up at y equals 1. This one is approaching down here at -2. Interesting. Okay, so something to think about is that this original one started out with a +0 at the end, but we don't say +0. You don't say, oh, I'm 16 + 0 years old. Like that doesn't make any sense, right? We wouldn't say that. So we don't say y equals 2 to the x + 0, even though there technically is a +0 at the end. That +0 is the shift up or down on the y-axis. And so that you can see that we started at 0, 1, and we went up 1, right? That's what that +1 did. It went up 1 from 0, 1 up to 0, 2. This is a shift down 2. And so we went from right here at 1, we went 1, 2, down 2. It even moved our asymptote up 1 or down 2. So if you have a number at the end that's not up in the exponent, that's going to tell you the up or down. The number that is just a constant, just a plain old number. Okay, let's take a look at one more shift, and that is shown here. All right, so we've got our same shape, right? But we definitely have it moved over. And so I see that a difference here is that I've got x -3 and x +4 in the exponents. Well, this shape has moved over to here, right? That's kind of where that turn is, like I'm seeing here. It moved this way. That's 3. It moved right 3. This one has moved this direction. And I just noted the wrong one. Here's the curve. There it is. It moved left 4. So left 4. Okay. So x -3, I would have thought would have been left 3, but it actually goes right. X +4, I would have thought was going right, but it actually goes left. If it's up there in the exponent in an exponential, it's going to do the opposite of what it looks like. That's just the way it works. Same as with a quadratic. If you've already studied quadratics, you know that in the parentheses, it does the opposite thing. The left or right is the opposite. And if you haven't, that's okay. But just know in the exponential, if it's -3, that actually means it's going to go right. If it's a +4, it's actually going to go left. So, yeah. So there's our, oh goodness, can't even say it. Those are your transformations as far as shifts goes for exponentials. See you next time.